we have log base 5 of 3 times 8, okay? We want to pull them apart, okay? So if we want to pull them apart, right now, what is the operation that's occurring in here? Multiplication. What does multiplication turn into? Turns into addition. So we got 2 things in here being multiplied, so we should have 2 things out here being added. Does that make sense? They should be base 5, both of them. And now what is going to go here? 3 is going to go there, and what's going to go here? 8. So we're just so yesterday, day before, we were starting with this side, going to that side, right? Okay. Now we're reversing the order. Yeah, I don't have these examples on the notes. What if we go log base 7? Let's go 3 times AB. Okay, you can put A here. Yep. Okay, so we have 3 things we have a product of 3 objects, right? Okay. So we have a product of 3 objects, and when we separate them, there's going to be a sum of 3 things. And because products and sums are, what's the property? They can move things around and still get the same product, and get the same, so they're commutative. So I can write that as log base 7 of A plus log base 7 of 3 plus log base 7 of B, or any order. If you want to go log base 7 of 3 plus log base 7 of A plus log base 7 of B, you can. If you want to go backwards and write log base 7 of B plus log base 7 of 3 plus log base 7 of A, you could. They're all equivalent. Is that okay? What if we go, let's go log base 10 of 3, yeah, x squared. Log base 10 of 3x squared. Okay? Now, here's what we're doing here. Remember what yesterday we talked about when we were combining them, we're doing essentially order of operations. So exponents needed to be done before we attacked the addition, subtraction stuff, right? Well, when we're undoing these, when we're pulling them apart, we're actually approaching order of operations from the reverse direction. So it's PEMDAS backwards. So instead of addressing the exponent first, you're going to address the product here first and turn it into a sum. Does that make sense? Good, good. I'm going to go, so that's the fun. I'm going to go one step slower or more direct. So right here we've got 2 things being multiplied together, right? 3 and x squared, okay? So we're going to separate those using addition. Okay? So we've separated them using addition. Now, Maya, what'd you do with that power of 2 on that x? You put it in front of the log, okay? We had that property that said exponents need to come out in front. So this gives you log base 10 of 3 plus 2 log 2 log 10 of x, okay? Now here's maybe a logical reason why we do that. What is x squared? What's another way of identifying or stating x squared? Write it as x squared as a product of things. Times it's got to be x times x, right? If I write it that way, can I write this as log of 3 plus log of x plus log of x? Does that make sense? How many log of x's do you have now? You have 2 of them, so we can merge those as 2 log of x's. Now, why am I not writing the base to 10 in there? Okay, so if it's a common, if it's a 10, you don't need to write it. It's called the common log. Now, if we wanted to check to see if we've done this correctly, yes. Somebody's art project. I think that's an art project. All right, so if we had log base 10 of 3, now I'm not going to use x because Desmos will try to graph it, so I'm just going to use a in its place, and I put squared. So that's what we started with, right? Now we are saying that turned into log base 10 log base 10 of 3 plus 2 log base 10 of x, but we changed x to a, right? So now, do you see how when it says a is 1, that it's giving me 0.477 and 0.477 back? When a is 3.6, it gives me the same numbers back. When it's 7, it gives me the same numbers back, and those are enough kind of specific cases of choosing an input value when we see the output is identical to tell us, yeah, you've done this correctly. Does that make sense? Okay. Let's do... Okay, well we can address that here in a minute. Or I'll help you with it. I'm just going to say log, so this is base 10 again, of 10 x cubed over 8. Okay? Now, what I want you to understand, and this is going back to what we talked about in, it was probably the first week, might have been the first or second day of class. When we do division like this, the division symbol is ultimately, in our order of operations, is a grouping symbol. Okay? Basically telling you that you're going to address that numerator first. Okay? So how can I rewrite the numerator? The log of what? 10. Okay? Plus, well, so the 10 took care of that term, right? But I've got a product of things here. I got the 10 and the x cubed, right? So shouldn't it be plus log of x cubed? Does that make sense? So I'm going to take care of that first. Now the division, and this is a nice way to remember it, that division sign is horizontal. It's like a big minus sign, isn't it? So then I could go minus the bottom, log 8. Now what can I do with this 3 right here? Bring it out front. So I have log of 10 plus 3 log of x minus log 8. Let's give that a shot, see what that. My allergies have been awful, so I apologize for the coughing and. Nah. All right, so if we have that now, I used x, so you see that's graphing over, that's okay. If I go log, so let's go log of 10, okay, plus then 3 log of x, plus then log of 8. Did I do something wrong here? Oh, subtract. Thank you. And there you see that the red curve and the blue curve are identical. So that is showing us that no matter what x value you plug in here, if you plug the same thing in here, you get the same result. Is that okay? Let's do another one like that. Let's go log. We'll just stay with the base of 10. I think that's just easier for when we go to Desmos to check things. Let's go AB over MN squared. Yes, MN squared. Yep. And we'll talk about some properties. So log of 10 could be rewritten as 1 because it's base 10. So when we raise base 10 to get 10, it'd be 1. So that first thing might, if you type it in, they might say you can simplify. But okay, so in this one, we are going to address that first. Address the numerator first. So that's going to turn into what? Log A plus log of B. Okay? Now, here's where this is a little bit different because now there's a product on the bottom, right? Okay? So in the last one, there was only a singular thing on the bottom, so we just put a minus sign here, right? If there's a product on the bottom, you're subtracting that sum then. Does that make sense? So what we need to do is make sure that we put, because there's a product down there, we put parentheses here. Just going to open a parenthesis. And now, let's just deal with log of MN squared. So if it's a product turns into addition, right? So it's going to be log of M plus log of N squared. Is that okay with everybody? Okay. And that's because of that product down the bottom. Okay. If we go through the algebra here, okay, where's this going to go first? Where's that exponent going to go? In front. So I'm just going to rewrite everything exactly the way it is, except we're going to bring that down in front. So we get something like that, right? Okay. Now this minus here tells us to distribute, correct? So we get log of A plus log of B minus log of M minus 2 log of N. Okay? And that would be the final answer you type in. But what I'm hoping you see here, because you can do this two ways. You can write it the way we did here, okay, as minus this product, okay, which the product of M and N squared, but turns into this, subtracting this sum. And then you can distribute that through. But what do you notice? Everything that was in the bottom now has a minus sign attached to it, right? So if you want to go straight from this, it's like A, B is a sum. And then because M and N are on the bottom, I know I'm going to subtract M and then subtract N. You can do that. Okay. Now let's check. Let's see if that is accurate. So log of AB over MN squared. And then we had log of A plus log of B minus log of M minus 2 log of N. and it says create slider for all those. So if I allow those values just to be random, do the two end up being the same? Okay? And my only worry is that if you were to get this wrong, most people are going to get it wrong because they'll change that to a plus sign because they didn't realize that they needed to distribute the negative through on the bottom. Okay? But that's the number one error there. And obviously then if you check things with Desmos, you can see that you did make an error. You can go back and reevaluate your process. All right, I would like. It seems like you guys got the hang of this, which is, to be honest with you, I think logarithms, and when I've taught this in the past, has been one of the harder things for people to get a grapple on. Okay, but I'm glad we are. I want to talk about a notation thing. I think there was one question in your homework that showed this or used this. It used a different phrase instead of logarithm. It said, so we've been using log, and then we put our base here of whatever, okay? And your homework, you might have seen, did anybody see this? ln, and then they put that there, okay? Now this is, so there was a guy named Leonard Euler who was very interested in looking at a graph of 1 over 1 plus n, or 1 plus x, whatever you want to use, and what it evaluated to as x went to infinity. Okay? And what he found out is that it generated a number like pi, but the number we call it e. Okay? And if you go to Desmos, so I say it's like pi because it's irrational. Okay? It is that number right there, 2.71828182846. That goes on forever, never ends, never repeats. And it's, like I said, I believe, I want to say it was 1 divided by 1 plus x. No, 1 plus 1 over x. There we go. It's that as well, that doesn't make sense. All right, it's not a big deal for what we're going to be doing with this number, but this Leonard Euler, he was interested in taking this function and seeing what happens when we go to infinity with it. And if we look at that, that's very similar to the function that we used when we started doing the compound interest stuff, okay, where the A is ultimately the number of compounds that get done to an account, okay. But as we go, and obviously if A is 0, we get division by 0 right there, so it's undefined. But as A gets bigger and bigger, he was recognizing that, you know, at 7,000, these numbers right here are pretty much static. They don't change, but the ones after it do. But once I get up far enough, okay, now we're seeing that that number is not changing. That 2 is not changing. And basically he just went through and did evaluation after evaluation after evaluation, and he started to find out that as the A value got very, 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 very large, even much larger than the 100,000 I have in here right now, we start to approach that number right there, which is going to never end and never repeat. Okay, so it's irrational. We call it E. It's called the natural number. Okay. Sometimes in science, have you guys ever dealt with in science chemistry class Avogadro's number? Okay. So this is a component to that. Okay. Usually in science they call it Napier's constant. But nonetheless, that's what we're dealing with here when they say ln. Okay. And I believe it's called ln because of I think the Latin the Latin way of the way that they say natural. We call it the natural logarithm, okay? Because we're using what we call the natural number, but in Latin it's like logarithm naturale or something like that, okay? So ln. What this means, so if I say ln of x, that is identical to log. Instead of a base of 10 or a base of 3 or a base of 7, it's the base e, okay, of x. So I just want to show you in Desmos that graph. So if I go ln of x, it graphs that black curve right there, which is identical to saying log base e of x. Is it okay with everybody? Okay, so we use it so often, especially when we start talking about solving equations, that do you like writing those little subscripts? No. If you think about typewriters, okay, it's a pain in the butt using software right now to write log of a base, okay? So it's more convenient to use the natural log instead of any other logarithms when we solve equations. So they use ln. But what I've always done, because it gets confusing, I think, especially the first time you've seen it, is that whenever I see ln, I rewrite it by hand as log base e. I go through all the work that we've been doing, knowing now that e is that 2.78 number, do all the work that we've been doing with other logarithms, and when I get done and my answer has log base e in it, I rewrite it as ln. So I'll give you an example of what I mean by that. If we have ln of, let's say, let's go, say it again. Okay, ln. That's an L. So 1/8 ln, and now tell you what? Okay. Like that. Okay, so let's go ahead. So what they're when they have multiple logarithms, okay, they want you to condense them, right? Okay, so if they start you with multiple ln's or multiple logs, it always means that you're going to write your answer with one of them, only one ln or one log. If they start you with one log or one ln, that means you're going to write your answer in multiples. Okay, so here we got multiples, so we're going to write our answer in one. So what do I do with this 1/8 first? Becomes an exponent for that y, right? So we write this as ln of y to the 1/8, okay, plus then ln of z, right? Okay. Now, what are you going to do? Okay, so we'll go ln, and because this is addition, turns into multiplication. So 1/8 y to 1/8 times z, right? Now, I'm not sure how Math Excel is going to accept this. Probably like that. But you could also do this. 1/8 is the 8th root. So you could write it that way. Okay. Eventually, somebody might like to write this way. 1/8 ln is log base e of y, plus then log base e of z. I can go log base e of y to the 1/8 plus log base e of z, and then I have log base e of y to the 1/8 z, and they're the same. Okay, so these two things should be identical. So what I always do my work with these, regardless of what I'm doing, I always write as log base e when they show me ln, and then when I get down and say, okay, now this is my answer, I'm going to type it in as this. But they'll probably balk at that. They won't like that. So then I take that and rewrite it as ln because it's the same thing. So what is your question on your homework? What is it? Do you know what question? All of them? All right, so let's all right, so let me open up an assignment and we'll just practice some. So 7-4 preview. Do you think it did it on the first one? Okay. 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 So here, let's just do mine here. It says log base 9 of 3. So what we're going to do is we're going to rewrite this as, because it's addition, so it's going to be log base 9. What am I going to do with these two numbers here? Multiply them together and get 81, right? Okay. So if I type that in, it is going to tell me I'm wrong. If I go log base 9 of 81, check answer, says that's incorrect. It says although your answer is equal to the correct answer, it is not the correct form. Be sure to read any instruction given the problem. And it basically says simplify your answer. Here's my question to you. If I gave you a question and you typed it in as 2/4, it's going to tell you need to simplify. You would simplify it to what? 1/2. So 2/4 is a symbol for another number 1/2, right? Log base 9 of 81 is another one of those things. So here's the question, and this is what they're looking for you to do. 9 raised to what number will come back and give me 81? Careful. 9 times 9, but 9 squared, so 2. 2 is what they're looking for there. And now we have simplified. So you've got the right idea. You've combined them correctly, but now it's saying go one step further and do what we did in section 7.3 and actually simplify that amount. Does that make sense? Not all of them can you do that. Well, if you've got them all written down, it shouldn't be. So this one I can't do that with, right? Because they give me A and B as values. Okay. This one I can maybe do that with. Let's see if we can do this. So what am I going to do? So I'm going to log. This is question 3. What's the base here when it just says log? 10. Okay. So what am I going to do with these two numbers of 3 and 2? Okay. So I'm going to write this as what number 10 raised to the what will come back and give me 6. So I don't know that. Like there is something. It's less than 1. It's because 10 to the 0 will give me 1, right? 10 to the first will give me 1 or 10. So it's between 0 and 1. But because I don't know, I'm just going to type in right now log of 6 and see what it does. Log of 6. And it says that's okay. Okay? And that's because I can't do, like the last one was 81, right? And 9 raised to what will give me 81. That's an easy thing to do. Nobody, unless you have a calculator, nobody is going to be able to find. No, I can't. So if I type in log of 6, that is the number, and I said it was between 0 and 1. That is the number that I should take 10 to. If I take 10 and raise it to 0.778151250.4, does it give me 6? Yes. But nobody knows. That's not common knowledge, right? That's not common knowledge like knowing that 9 to the second gives me 81. So if it's not a number that is common knowledge, then it's going to be okay to type it in as log of 6. Does that make sense? Keep working on that assignment. Nothing new for today.